Okay, I'm going to go ahead and get started. So thank you all for coming today. It's really great to see such a good turnout, and I'm really excited to be here in Munich. My name is Mano. I'm a developer advocate with Google, and I'm going to be talking today about Google App Engine. So let me talk a little bit about what I'm going to do before I do it. There's actually two talks today, this one and a talk this afternoon, which will be very similar to this one. I'll just probably go a little bit faster through the overview and spend more time talking about the code. So I want to encourage you to sort of think about that. We're calling that the more advanced version. This is the more basic version. You'll get largely the same content, but there'll probably be a little bit more in the advanced one, but this one will spend a little bit. Yes, I see somebody's now sneaking out because I said that, which is fine. That's why I'm telling you. You probably get, I'll spend a little bit more time on the overview and the sample code in this one. So I also want to say I sometimes end up talking a little bit quickly, and I had a little caffeine this morning, so I might end up speaking really fast. If you have any questions, feel free to raise your hands. Do we have any microphones for people to ask questions? Anybody know? No, it doesn't look like it. So I will try and repeat any questions that you ask because we are videotaping this. But like I said, please, if you don't understand something or if I've spoken too quickly, just raise your hand. The important thing here, or if you're just interested in any particular aspect that I haven't gotten to yet, please raise your hand and ask, because I'm here more for you than for me. What is interesting to you is more important than what's interesting to me. So that being said, I'm also going to have a lot of time at the end for asking for questions. So if you have any questions, then please do ask that. Okay, so this is the agenda. So I'm going to do a quick, probably not as quick as I will this afternoon, overview of Google App Engine. I'm going to do, included in that will be some of the frequently asked questions about App Engine, and then I'll pause for any questions that you have. Then I'm going to do a short application walkthrough, show you some of the basic code. If you were in the code lab that started last session, I'm going to talk about the Wiki Stage 1 application that we use for the code lab. And then after that, I'm going to go into some of the best practices for using Google App Engine and talk to you specifically about some code that for generating counters, which is one of the more difficult things about distributed systems, is getting an accurate count of the number of entities of a particular type. If any of you have seen Brett Slacken's talk from Google I/O, where he talked about building scalable web applications using Google App Engine, I've blatantly stolen some slides from him, so a lot of the content is duplicated, but this allows me to talk about a few things that you need to know for building applications on Google App Engine. So that being said, I'm going to go ahead and dive right into it. Okay, so you saw this slide this morning at the keynote, and unfortunately, Chris actually stole some of my jokes about Google App Engine. But because this is on video, I'm going to go through this. I want to talk a little bit about this to remind you why we're here. So these are some of your traditional challenges using Google App Engine. So normally when I give this talk, I don't have a screen that's so far ahead, so I can jump up and point at things. But if you'll notice on your right side, my left side, there's the LAMP stack: Linux, Apache, MySQL, and PHP, or some other P-named scripting language like Perl or Python. This is a traditional stack. It's a great stack for building web applications. There's a lot of resources out there. There's a lot of advice that you can get. There's a lot. It's a very robust system. But the problem is when you start getting additional load on your applications, you have to start adding things. You have to start adding. You'll notice on the far right we've got machines. You have to start adding machines. You have to shard your database. You have to do load balancing between your different machines and your different databases. And as you add more users, that can add more hassle to that. You'll see there's some of these other boxes that we think that people have to worry about. Monitoring of your application, making sure it's up, making sure that you've read all your logs, that your configurations are set up, and there's a constantly changing. And then there's the box in the middle, which as Chris pointed out this morning, it's cash, that's C-A-S-H, which means money, not C-H-C-H-E, which we'll talk about the memcache later. And this is, all these things cost money to do. That's the basic problem. Money, and the one thing I guess we don't really put in there is time. All of this takes time, effort, management, and money for you to develop. And that takes time away from you building your content for your application, building the actual thing that makes your application different from every other application that's out there on the web. So this is the problem that we're trying to solve. And so the solution is running your web applications on our infrastructure. And I'm going to say this once right now. People ask me, what kind of applications run on Google's infrastructure? Well, web applications run on Google's infrastructure. And this is what people are trying to point me. Well, but do you mean business applications or Gmail? No, it's any web applications can run on Google App Engine using our infrastructure. And our philosophy is that it's easy to start and it's easy to scale. Basically, you build in a little bit at the beginning about scaling, and you don't have to worry about or touch your code for scaling probably ever again. Or if you do, it's a very minor adjustments. I have talked to developers who scaled up from 0 to 7 million users in a very short period of time, and they never had to touch their code for that scaling. They just added more features. So I want to talk a minute about this because my slides don't, I think, fully pull this out. With Google App Engine, you never have to worry about what machines your data is on. You never have to worry about load balancing on your machines. You never have to worry about whether or not there's enough room in the data store. You never have to worry about any of those things because that's what Google takes care of. You don't have to shard databases. None of that stuff. None of that stuff that's inherent in scaling your application do you have to be concerned with. That's what we're here for. We've already solved this problem. You've used Gmail. You've used Google.com. You've used all of, hopefully many of our applications. They all run on this same basic infrastructure. And what we've done is we've exposed APIs to that infrastructure so that you can utilize the same tools, but you actually use them more easily than we do. Okay. So how much does it cost? It's free to get started, and we made this commitment that it will always be free to use this basic plan for Google App Engine. 0.5 gig of storage, 2 gigabytes of bandwidth, and 5 million page views a month, 2 gigabytes of bandwidth a day. So this plan will always be free to get started. Then, if you want to think about how much it will cost over that, you will only ever pay for what you use above that free quota. So this is there's no monthly charge. This is our expected pricing model. We haven't nailed this down. At this point, you can't pay us for this. We won't allow you to. We don't actually set up an infrastructure to do that. But we're committed to doing that by the end of the year. So you can get, you pay by CPU usage, storage, bandwidth incoming, and bandwidth outgoing. the way we think about this is if you take the basic free quota and you double it, it will cost, so you use that free quota and that much again, it'll cost you about $40 a month. But remember, just to say it again, you only pay for what you use. Okay. So I want to always say this beforehand. Python, so App Engine runs on Python, or it's better to say your applications in App Engine run on Python. We have a Python runtime. We'll have other languages later, but at the moment it's just Python. What you cannot do with them is write to your file system, open a socket or access another host directly, spawn a subprocessor thread, and make other kinds of system calls like signals. We do allow you to communicate with other applications, whether it's other App Engine applications or anything else, through a URL fetch. So you can do HTTP calls. But just want to call out, you can't do any of these things with App Engine. App Engine relies on pure Python, something I should probably put somewhere on this slide. So pure Python means you can't use a C library that uses Python using a C library. It has to be all entirely within Python. However, you can, any pure Python libraries, you can incorporate into your own applications. Okay, so what's next? More languages. I cannot tell you which languages are coming up, but I can tell you we are working actively on new languages. Why can't I tell you which ones? There's a variety of reasons which I can't really talk about. No, I mean, so let me say this. Google in general does not like to play the game of, we're going to release something in a year or two, and it's really going to be great, and let's give you a little preview, but you can't touch it for a while. We don't like to do that. We don't want to set up your expectations for something that may or may not come out, or may not come out on the particular date. In general, we don't talk about where things are going with our APIs, with our applications, with our platforms. The App Engine team has decided to talk about some of these things. These are, for instance, this is a list of things that are coming. Because we're in this free developer preview, and we know that people want to build their businesses on it, and they want to know what to expect. However, we're still going to be kind of secretive about some things. It's just the way it is with Google. And if you ask any other developer here, any other advocate here at Google Developer Day, you'll receive probably similar answers of, I can't tell you. Okay, so what's next? More languages, as I said. The ability to purchase additional capacity, which I've already mentioned. Yes?
Does more languages only mean like languages, or could it be different kinds of frameworks as well?
We have said more languages. Okay, so we also want to give you the ability to do large upload and downloads. So currently in Google App Engine, we have a bulk upload process, so you can bulk upload a CSV file to the data store. We don't currently have a way for you to download that data directly using CSV. You can always write your own scripts that output the data, but we don't have a current way for you to download it. We have committed that we will do that. We're committed to data portability. It's a very important value at Google. We just haven't actually defined the best way of doing it. And there's a discussion on our developer forum if you want to, suggest different ways or want to participate in the discussion of how that would actually look. We also want to support offline processing. This is something that people ask me about quite a bit. Can I run a large, a long-running process that creates tiles out of a huge image, for instance? So currently in App Engine, all requests everything happens through an HTTP request, which is a really convenient mechanism, but the HTTP requests have to have a response within 10 seconds or the request fails. That makes it hard to do large statistical computations, for instance. And we're aware of that, and we're aware that that's something that people are interested in, so we're telling you that's coming. Large file support. So we know people want to do things like have media files, serve videos or large images, that sort of thing. We're going to add support for that. Right at the moment, you have no write access in App Engine to the file system, and you have every entity has to be no larger than 1 megabyte. Also, all responses have to be no larger than 1 megabyte. So these are some limitations that are built into App Engine to increase the efficiency and the speed of applications. And we're also aware that people want these large files, and we're working on that as well. Another thing people ask about a lot is, if everything's happening through an HTTP request, how do I run a cron job? And currently, the only way you can run a cron job is you run the cron job on some other server that pings App Engine with an HTTP request every X number of seconds, hours, days, however often you want to run it, and then that process has to complete within 10 seconds. So we're aware that cron jobs are really important to people. We're going to add those as well. Okay, let me go through the FAQs, and then I'll stop for any more questions. Okay, so what about an SLA? So a lot of people want to know, are we going to provide a service level agreement? We're actually looking into the best ways to provide this kind of information to you. Currently, what we've done is we've added, we've worked with cloudstatus.com, which gives a uptime report on the current uptime report on Google App Engine. You can look at historical data as well. We haven't figured out the best way to provide you with an SLA, the best things that we can include in that would give you the most information that you need. So we're working on that piece of it. Another thing people ask us about is lock-in. As I mentioned, we're going to add large downloads, bulk downloads, so that you can get your data out of App Engine whenever you want. But there's another piece of lock-in, which is code lock-in. And we're concerned about that. It's hard to have a distributed system that we run and then allow you then to port that code to somebody else, because nobody else is running something exactly like App Engine. So what we did is we created a development server, which allows you to run App Engine within your own environment on your own machines. Now, of course, that means that Bigtable, which is the big piece of App Engine, the data store, is running on one machine. Well, that's kind of a problem. We recognize that. But what we've done is we've released the development server as an open source project. So you can take that and you can work with it how you want. There are other people who have created open source versions of Bigtable and other APIs that Google has produced, and you could then run those on other systems. We're, of course, always looking for ways to improve this portability as well. So a lot of people ask right now, you can't pay for more quota, but how do you get more quota? We actually have a page you can request, and they're fairly routinely, requests for more quota are fairly routinely honored. And then the other thing that people ask me all the time is, what's your language? And yes, I've mentioned this already, but it bears repeating. I can't, unfortunately, tell you right now. I can tell you it will not be COBOL. It's not likely it'll be Fortran or QBasic. That's about all I can tell you. Okay, so are there any questions right now? Oops, I'm going back and forth here. Are there any questions about anything I've covered, any direction? Because what I'm going to do right now is I'm going to go and take a look at some code. But anybody have any questions about our direction, about what we provide, anything like that? Okay. Well, if you do, stop me, ask questions. This code is available for download. This is the URL, which is really hard to read up on that screen. So basically, just do a search on Google App Engine Code Lab and look for the download page. That's where it is. I think it might also have been in the description, online description of the Code Lab. You can follow along with this if you want. I'm going to go ahead and take a look at this. So you may notice I'm using Eclipse. We have an article and also now a video online about how to configure Eclipse to use to work with Google App Engine. Currently, so what I've done is I've used PyDev, which is an open source plugin for doing Python development. And then I just did some configuring to make sure it worked with the App Engine libraries. And then you set up a run configuration. So I know a lot of people really like Eclipse. It's pretty easy to set it up. I think it took me about 15 minutes to get it all working. And then you can run it within that development environment. So you'll see at the bottom the console. In fact, if you run Google App Engine, you'll see that these are actually some of the messages that print out at the console when you run the development server. Okay, so what I want to do with this is highlight some of the basic features of App Engine. And the most basic piece of every App Engine application is an app.yaml file. Now, the app.yaml is a configuration file. Basically says this is what the application is. This is what the runtime is, and then it has handlers which direct where you would put where the script would send particular requests, which scripts would process those. So let me say that again. I said that a little bit awkwardly. The handlers say when a URL request comes into to the application, the handler says which script handles it. Then the script will make a decision about how to handle that, and I'll talk about that in a second. So let me just go through this line by line. The application is the application name. This, you see here it says Wiki 1. When you're running on your development server, the application name doesn't really matter. But when you're running it on appengine.google.com, you have to set up a name before you start uploading code. And so this app.yaml tells which application under your account it's running on. And then that name, if this were actually running, if this were the actual name, application would run at wiki1.appspot.com, unless I set it up to work on my own servers, or my own domain rather, in which case it would go direct there. Okay, the version number is the next line. The version number is something that you yourselves have control over. This is the major version number, 1, 2, 3, 4, etc. appengine.google.com, that will handle the minor version numbers. So every time you make an update, it will add, 0.1, 0.2, 0.3, whatever. It'll increment that so that you can keep track of that. And actually, we give access to older code. You can actually, you have to look at the documentation and figure out directly how to do this, but you can actually change the URL so that it's pinging an older version of your code. Okay, the runtime is Python. Don't bother trying to put in C# or any other programming language there. It won't actually change. It won't actually do anything. But that's a hint to you that we are planning on doing other runtimes. The API version is our version of the API, so that's right now the only version available is 1. Again, that's a hint that we're going to make changes. There will be different versions there, but we just haven't implemented them yet. Okay, and then there's a list of handlers. Every item in the list starts with that dash, and then has a URL pattern. So URL, colon equals, and then some regular expression. So this is a really basic one. All it says is anything coming in, send it to the script main.py. and main.py will then make decisions on how to handle it. The thing to realize is that you can have multiple URL patterns. And as I said, this is a regular expression. This is not a URL expression, so it's not .star, it's anything. You can use these handlers, and I don't have an example here, and perhaps I should, to say, to also do a few things. You can define where static directories live, so that all your scripts will know which particular directories your templates live in, for instance. And then you can also use this for authentication. So Google App Engine provides you with a user API, which allows you to do some basic authentication using Google, Gmail, Google accounts. And you can use a basic Google accounts, or you can use Google Apps for your domain accounts. And you can also restrict things to administrators, people who are registered with the application as administrators of the application. Okay, any questions? Looking at the time, I might start going a little bit more quickly. So if you have any questions, please let me know now. Okay. So the next thing I want to show you is main.py. This is the script that actually handles everything. So you'll see here I've got application equals webapp.wsgi application. And here I'm doing the thing that I always hate it when people do, is I'm reading code to you, which is probably not the most effective way of communicating it. But you'll see here that you'll see that we created basically a list of handlers. So you'll see here, this slash says anything that goes to slash in the application will go to the main handler. Anything that goes to view, followed by these regular expression, goes to the view handler. Anything that goes to edit, edit, save, save. And then you use this to run the actual application. So when this script runs, it runs, and then it basically registers these request handlers. And so what do the request handlers look like? They look like this. So this is the main handler. In this code, we actually create a base request handler, which perhaps I should just show you that basically. The base request handler has within it a generate function, and that's it. And the generate function is used to generate a template, which is an important piece of what you're doing. The main handler, so you'll see here it defines a function get. Now, there are certain sort of reserved function names, get, post, delete, etc. And if you look at those, you'll know that those match HTTP request names. So if an HTTP GET request comes in to slash, the application sends it to the main handler, and the main handler says, okay, this is a GET request, so I know how to handle it, I'll send it to the GET function. So anything, you can define other function names, but anything that comes in as a GET is handled by the GET function. Anything that goes to post, handled by the post, etc. And all this does, and the main one is it redirects to a start page. And let me show you what that looks like. That's it, start page. So the view handler, which is for viewing a wiki page, takes the page title and get, and then it sends it to, what it does is it looks up. Let's do a quick look at this. This is querying the data store. Sorry, this doesn't all fit on one line on my screen. It creates an entry object that basically is, it queries for all wiki pages where the title is the same as the page title, and then it gets the first one back. So the entry takes the first object that meets those pages. And if it's found and the entry has a body text, it then displays it. So I'm not going to walk through all of it because I realize I need to move on to some of my other slides. But that's the basic method that it does. And then if it doesn't exist, then it defines the wiki body and author as essentially empty strings, and then it sends it to this particular template with these particular values that generates the response, and then it writes that out. And then the edit handler does something similar, but it allows you to edit the object, and if you click on save, it saves the object to the data store. Okay, so that's interesting, but it probably would help if you knew a little bit about the model for the page, and this is a very simple model. So I think I mentioned this. App Engine is built on Bigtable. Bigtable is essentially a big hash table distributed over many systems around the world. To get to store items in there, so when I say it's a big hash table, another way of thinking about it is an object-oriented database. You create a model of the object, which defines some properties. And then when you create the object using the class constructor, then you have to assign values to those particular properties, including the title and the body and the author in this case. Now you'll notice that we've defined this model to have certain types of properties, so that the title is a string property. The body is a text property. So if you're familiar with relational databases, these are sort of familiar to you. String property is a Python string. It stores that. It's limited to a certain number of characters. The body is a text property, which is a undifferentiated blob of text as far as App Engine is concerned. It's not indexed, in other words. And that can be of any size, up to 1 megabyte, because every entity in the data store can only be 1 megabyte. And then the author is a user property. Now, this is not as familiar to you, but basically we have our own user API, which allows you, as I said, to do authentication using Google's accounts. And then you can store that information in the data store using the user property. Okay, so to actually store this data, I'll show you the save handler here. The save handler queries the data store and looks for an entity of this type, of this title. And if it exists, what it does, it creates the entry. If that entry exists, then it assigns the body and current user to that entry. So entry.body equals body, entry.author is the current current user. Otherwise, it creates an entry, and I just skipped around here. It creates an entry using the class constructor, creates a wiki page, gives it a title, a body, and an author. Then, to store it in the data store, all you do is on that entry object, you just say put. Now, if I were to delete this entry, all I'd have to do is call the delete function on that entry. And that's all you do to create or delete objects. I'm going to talk a little bit more about entities in a little bit. So this is pretty much the end of this basic code walkthrough. This is your introduction to Google App Engine's overall structure. Are there any questions before I switch back to my presentation? Yes.
The GQL, is it similar like SQL?
Okay, so we always say that it is, but then I always qualify it and say it's really not. So you'll see that it looks similar, right? It says where title equals, and then you'll see that it says title equals :1, and then that's basically a substitution mechanism for doing it. But GQL is much more limited than SQL because SQL allows you to do all sorts of transactions within it. You can insert, you can update, you can create tables and databases and all that sort of thing. GQL is optimized, and what that means is it's really fast, but all you can do is query for objects from the data store.
But you can do that joins?
No, you can't. So it's not a relational database. I'm going to say this a few times. It's a little bit harder for people to understand. Joins are expensive in terms of how they work, in terms of CPU usage, and they take lots of time, and they require lots of indexes and all that sort of thing to do efficiently. So Bigtable doesn't do them. Now, we do allow you to store references to other objects in your entity, but the name Bigtable is a little bit it's a little bit misleading because if you think of a relational database, you think of a table, which has a schema, and every row in that table has exactly the same properties. Bigtable, that's not true. If I change the model definition of this wiki page, all entities that were already created would not have any knowledge of new properties that I added to it. And all things that I created afterwards would. All entities that I created afterwards would. So this is not a table. It's a bag of objects. It's a hash table. It's not a database table. So there's no joins, which is probably the biggest problem that people have getting around. You can do relationships through this reference property, which is really powerful. And I'll talk a little bit more about that, but there's lots of resources online. But it's not the same kind of thing. So in GQL, you don't mention multiple entity types in the same query. Yes. Yes. You.
So how would you handle references to other objects?
How would you handle references to other objects? There's a reference property. One of the properties that you define in your model would say, give me a reference to another entity. No. You would have to set up a process that would go through and update all your existing entities of a particular type. It won't necessarily blow up. It just means that when you do a query on particular entities on a particular property, say that's new, you'll not see anything that has no knowledge of that property. Yes?
Can you do sorting and pagination?
You can do sorting within the queries. One thing to keep in mind is every query can return a maximum of 1,000 objects. So you need to think about how about that when you're creating your entities. That doesn't mean that you only create 1,000 entities of any individual type, but you can create a unique field, for instance, within the entity that you can then sort on and only get things that are greater than that particular field. That's one way to do it.
Pagination built into the API to Bigtable, or do you have to build it yourself?
Excuse me. You can do offsets. You say, return these things offset by 25 or 50 or 100. So return me this query, but shifted. So there's that piece of it. You probably want some more control over that, so you'll probably have to set up some pagination on your own. When you think about App Engine, think about every decision that we've made is designed to increase speed and performance. So if you ever wonder, does this exist or does this not exist, The probability is that we'll have made the decision that would make it faster. I saw his question first.
Do you have a way to generate the model definitions from UML or not model?
Do we have a way to generate the model definitions from UML? Not currently, but I wouldn't be surprised if somebody's working on a project to do that. And certainly you could do that. I think it's a great idea. One of our philosophies is we're providing you with a bunch of APIs, but we're not going to overload that. We're not going to say there's a whole bunch of APIs in here, and every time somebody requests something, we'll put in more. What we'd rather see is a bunch of Python libraries that did that for you.
So if I come to the point where I want to extend my application, and if I have my table and I want to put in more fields in it, how can I actually update my table spaces? Is there some way to export the data or re-import it?
So how do you update your table if the one you want to make changes to your schema? So there's a couple of things to keep in mind. One is that you can basically what you would have to do is set up a process which would go through all your existing entities and add that property. So you just pull it out, add the property, put it back in. That means that's a bunch of work, and you probably need maybe set up a JavaScript page that would go through and query the first 25 and then the next 25 and the next 25 just for performance sake to go through that. Another thing is you can use an expando model. So expandos allow you to arbitrarily add properties to models. And there's some limitations on expandos. I don't want to go too much into it right now. But basically, you could, even at runtime, determine the name of a property and assign it to a particular entity. Other questions? Yes?
You're talking about performance?
Yes. I'm talking about what? Yes. So the big table is designed to be fast. Yes. What does it mean? I don't have statistics on that, but it's when it's designed to be fast for querying. It's designed to be fast for sorting. It's designed to be really fast if you know the key of an object, and I'll talk a little bit more about that. You can really quickly pull it out. So if you identified your particular object. Yes. Yeah. Yes.
What other limitations? So in items or the size of the table or something?
So what are the limitations on the entities and the size of the table? There's no limitation on the size of the table because you're not really dealing with tables. There's not a limitation on the size of big table itself. It's huge. I'm sure that, on the Google scale, there is. If you were to build Google on top of App Engine, you might run into some problems. But hopefully, as you were doing that, you'd be giving us enough money. We could add more data centers, and then it wouldn't be a problem. So on the individual entities themselves, though, there is a 1 megabyte limit to each entity. Now, what some people do is they'll shard their entity. Like if you want to store a large object, a large image object, for instance, you can shard that into. You create an entity group, and there's more on that online. I don't have time to get too far into that, but basically, you create an entity group, associated entities, so those will query more quickly, and you tile your thing into a number of different. Number of different objects, which you then return. And one thing I should mention, I don't remember if I mentioned before, every response is also limited to 1 megabyte. Yes?
How is actually my application and my data separated from others?
It is. We do that. We handle that There's no access. I mean, I can't give you the exact way that it's done because it happens on the back end. But essentially, there's nothing, you have no way of accidentally accessing or on purpose accessing somebody else's data store.
How are you handling conversational state?
Sorry, I saw his question first and I didn't hear yours, so. Yeah, so I'll talk a little bit more about this when I get back to my slides, but all but I think 2 of the properties are indexed, and the 2 that aren't indexed are blobs and text. So those are automatically indexed. You can also create your own indexes in the index.yaml file, and those will be automatically created. If you run your application on your development server, and you generate a query on that development server, run the query, it will automatically add it to your index.yaml file. But you can also do that by hand. And that takes a little bit of time once you've uploaded to the application. It'll take a little bit of time to complete that indexing. But you can look at that in on your development console. I'm sorry, somebody yelled out something earlier. I'm sorry, I didn't understand the question.
How are you handling conversational state? In every use case, it goes over multiple steps.
How am I handling conversational state is what I heard. The use cases, can you say it a little bit louder?
The use case goes over multiple pages, so you have
Over multiple pages. So you would need to do some pagination within the querying if you're producing so I'm going to guess what you mean is sort of like Gmail will display the first, say, 100 or 50 messages, and then you go to the next one. You'd basically be doing another query to get the next 50 out. Or you could store in memcache.
No, I was asking about the physical shopping carts scenario. So when you put your shopping cart together.
Oh, I see. Say a shopping cart example. You'd have to store that information. You would essentially configure the conversational state. So you would store particular steps within the data store or within memcache. Yes.
What about test-driven development? Is there something built into the framework, or do I have to develop it myself?
There's actually an article on doing unit testing. If you do a search, I think it's actually not on our site, but somebody's written an article on doing unit testing with App Engine. Yes?
And is it possible to import MySQL data, or
You'd have to do it as CSV. So you'd have to export the data to MySQL and then upload it as CSV. And again, one of the dangers is you're going to lose the joins. So you'd have to think about how you would configure it. So one thing people ask me a lot is, what about normalization of the data if I don't have these relationships between tables? And what I often suggest is you denormalize your data. You shove as much as you can into individual entities. It's actually kind of more fun, I think, way of developing. Yes?
so you read what you said is all about performance. You wouldn't want to handle complex data schemas with the application of the API because it's all about performance, right? And you do not store on databases at all.
So you said I talk about it's all about performance. We don't handle. You're asking if we don't handle complex schemas. Yeah, I mean, I think in terms of denormalizing your data, yes, I would recommend more complex database models or data models. But one thing you need to realize is that every entity has this 1 megabyte limit. So, make your decisions based on that. Yes? Yeah, data is essentially replicated around data centers around the world. So you don't have to think about backups. We handle that. One more question, and then I actually am going to go back to my slides because there's a few things I want to handle. Yes?
Can I access external databases?
Can you access them? If you can do it through an HTTP request, you can. So what you would want to do is if you have a MySQL database, is set up, say, a PHP or Python script on the other end that you can send a query to it, and then it would handle that and send it back to you. But that would have to happen within 4 seconds because our URL fetch only allows you about 4 seconds for the return. Okay, I'm going to go back to my slides. I'm not going to get through all of this. If you want to see the rest of them, come to my talk this afternoon as well. I know you want to spend your whole day thinking about App Engine. So I did the basic. So I'm going to talk to you right now about tools for storing data. So let's talk a little bit more about entities. Entities are the fundamental storage type for App Engine. As I said, they're a set of property name-value pairs. Most properties are indexed and efficient to query. The other large properties are not, the blob and text ones. One of the implications of this is you cannot do a full text search in App Engine at this point. We're aware that's something that a lot of people would like. We're looking into whether that's a possibility. Think about it as an object store. It's not relational. The kinds are classes. The entities are object instances. And then the relationship between entities uses keys. And the key is individual to the particular entity. It's not a key for the table. Okay, so I wanted to just review that before I talked about keys. So keys are the fastest way to query data in Bigtable. If you know the key, you can grab it very quickly. A key corresponds to a Bigtable row for an entry, and Bigtable basically you do a get on it, and it returns it. You can create your own user-defined keys if you use a key name, but you have to do it at creation of the entity before you put it into the data store. Once something gets put into the data store, it has an App Engine key, and that or the key name that you've set, that is set. You can't change that key. That entity forever then has that key or that key name. And key names are unique within entity groups, and if you don't assign an entity group, it is unique in all the things that don't have an entity group, which is essentially the other entity group. Okay, any questions on this? Okay. This is one of those fundamental things that you should think about when you're creating your application, is these keys. Okay, so the other thing I wanted to talk about is our transaction API. So we have a way of doing transactions so you can make sure that a particular operation happens or doesn't happen. And that gives you your basic ACID transaction, your atomicity, your consistency, your isolation, your durability. There's no queries in transactions, which means that you can't perform an operation doing a query. You can do transactional read and write, uses get and put, so I already talked about. And the common practice is to use a query to find what you need and then to transact with it using the get and put. Okay, so those are just some of the things that I wanted to go through. I don't think I have time to go through counters, but what I want to do is talk in general about them. So the way to count the number of entities, App Engine provides you with this model.count. So in the application that we were looking at, if we did a wiki page.count, that should return the number of objects that we have. But count won't return a number over 1,000. So that's a problem. And also, it's expensive to do a count because Bigtable doesn't operate on tables. And when you're in a relational database, a table sort of stores a knowledge of how many things are in that table at any given moment. So Bigtable doesn't do that. So that means you have to create a counter. And the counter is basically a counter for a particular object type, and then it counts the a particular entity type, and then it just, you iterate that counter. So you can do that. You could create one single entity that counts all, that is a counter for every entity of a particular type. But if you have frequent updates, you're going to get a lot of contention in there. You're going to have, if you're doing transactional writes, it's serialized, and that means it's very slow. So you're basically waiting for every transaction to be waiting to see if, waiting its turn on the, to add to the counter. So this is a fundamental limitation from distributed systems that, you just have all these limitations. This contention, and then you have, the fact that the entity doesn't store the number of entities of a particular type. So the solution is to use a sharded counter. Basically, you shard your counters into multiple entity groups. Each entity group is assigned to a particular entity type, and then you pick an entity at random and update it transactionally. What this does is, so then you combine all these particular counter entities together to add for your count. This reduces the contention by a considerable factor, 1 over n. And your sharding factor, the number of shards that you use, can be changed pretty easily if you want to increase the number of counters. If you're, basically dramatically increasing the number of people who are involved with a particular application. So what this does is it, and the code will probably be online in my slides later, but basically the rest of my talk, which I don't have time to go through the whole thing, would then walk you through the actual code of doing this. And I'll deal with that this afternoon. I'll spend less time on the overview. So we've got about 13 minutes now, and there were a lot of questions before. If there are a lot of questions now, I'd like to hear them. Yes?
Just back to the Wiki page example. When I want to find search or place the Wiki page, but then I want to kind of say something like tags for the Wiki page. How would I do that?
So how would you handle the search on the text of of Wiki pages? How can you add tagging for a Wiki page? So, right. So right now, a full text search you can't do. So I would just say you put a Google custom search engine on it. But that wouldn't be the right way to do it. I mean, that would be a way to do it. But what I recommend is creating a string list property for your Wiki page entity, and then you could store tags in there. You basically identify however many tags you think is appropriate and store that in there. One of the great things about Python is if you have a list and you're doing a string comparison on a list, if any object in that list matches the string that you're trying to find, it'll return a true. So that's a really nice feature of Python, which App Engine gets as a carryover. Yes?
Dimensional query, index structure, like entries or something like that, can I use to use like cases later?
Can you do multi-dimensional queries? Yeah. So you can do queries on multiple properties within a particular model. So you certainly can do that. The limitation at this point is that you can only do inequality on one property. So you can do multiple inequalities on that same property, but only one particular property. So you could say is greater than and is less than. This is, again, it's an efficiency thing. When App Engine is doing, when Bigtable is doing this this query, it's got to sort through all the entities of a particular type. And so to have multi-dimensional sorting would just be, it would be very expensive. So that's fundamentally the reason for that. But yes, you can do queries on multiple properties within the same, and you can do matching within as many as you want. Yes.
More from the front-end side, is it possible to have Google Web Toolkit frontends talking to that engine?
Well, Google Web Toolkit primarily runs on Java, and you have to have a pure Python library. So at this point, it's not possible. Although we really like Google Web Toolkit at Google. So, in the future, I certainly wouldn't rule it out if Java were supported. Other questions? Yes.
Python is a great language for handling XML, and I can't write to the file system. Is it
Yes.
possible to change the header of the file, for example, as we still don't have any sockets or anything else? So I modify the header of the file, and so I have like a solo XML file.
So you mean, you're changing the XML header of the file, or?
Just the output header of the Python file.
Oh, for the response?
Yeah, for response.
Yes, you can change any of the headers, any of the standard HTTP headers, and assign it a different MIME type, for instance. Yeah, absolutely. Yes. So the question is, do we have planned a plugin system like Rails does, which allows you to share the code, I assume you mean, of a particular application? No, at this point we don't, and we haven't announced any plans to do so. The way to do sharing is you can do data sharing basically through HTTP requests. Yeah, at this point, if you want to upload code that somebody else wrote for their application, you'd have to upload it through your standard upload process, and so it would be sitting on yours and theirs. Oh, so you mean is, do we have a central repository of those kind of application of that kind of code? Is that what you're asking? No, we don't currently. Google Code Hosting provides open source. It's an open source platform, so you can store code in Google Code, but there's not like a central particular place. We do have some samples that we've put the sample code for, and those are released in one particular location, but that we don't have a place that a lot of people can add their own code to. We do have a samples gallery, which does allow you to see the applications that people have coded, but not the actual code itself. Yeah. Yes. Is it straightforward to do the Django framework? Yes, so the Django framework we support is, I believe, 0.96. That's the default. People have ported 1.0 to App Engine. One of the dangers is App Engine has a limit of 1,000 files, and apparently, somebody told me, I haven't done this myself, if you upload Django 1.0, you're getting pretty close to that 1,000. But that being said, there's components to 1.0 that you can't use, which require some file access or access to C libraries, like GeoDjango, for instance. And those things, if you don't port those, then you gain that number of files back. But yeah, there are people who've already done it, and you can do. There's somebody who did a walkthrough on importing Django 1.0. But yes, it's really very simple. You basically generate this template, you send objects to it, and and the template loads the objects. So, yeah. Yes? I'm sorry, I couldn't. So what do we have out of the box related to authentication and authorization? So we have a user's API, which allows you to use Google or Google Apps for your domain logins. And as part of that, we allow basically 3 levels of authentication. One is no authentication, one is requiring a login, and one is requiring an administrator access. Now, administrators are set using the development console on an application, and administrator access is assigned to anybody who is logged into one of those development accounts. So that's what we provide. If you can find a pure Python library that handles authentication for you, then and port that in or develop your own authentication, then that certainly we encourage people to do that as well. Any other questions? I have time for probably 2 more questions. No other questions? Okay. Oh, yes.
Just numbers, how many engines or how many applications do you run?
How many users have created applications? So the only number I have is actually like 3 or 4 months old, and we had 100,000 accounts created. Of those, I don't know how many have active applications running, or we're just trying it out, but lots and lots and lots of people. It's one of our we have an incredibly active developer community, and we get tons of traffic through App Engine. Yes, last question.
In the App Engine, is there any session management built in?
No, you'd have to build in that yourself. You can store user information, which gives you access to their email address and their nickname, but that's the closest thing we have to session management. Okay, thank you very much. If you want, I have another session later this afternoon, but enjoy the rest of Google Developer Day.